All right, good afternoon and welcome to Master Talker online class. In today's video, we'll be talking about electric circuits and different types of electric circuits. All right, for me, and this is our second video on current electricity. Right, and if today is your first day of watching our video, please click the subscribe button. All right. An electric circuit is a network showing the flow of current from the source or battery through the resistors and other devices before entering back to the source. So let's talk about the types of electric circuit. The types of electric circuits. The first one is an open circuit. An open circuit. All right. An open circuit is one in which the source of electricity, that is the cell or battery, does not deliver current to an external resistance R, big R, okay, or load. That is to say that the source of electricity is not connected to an external resistance R. In this situation, any voltmeter connected across the ends or terminals of the circuit will measure the total driving force, that is the EMF of the circuit. All right, and then we have something like this. In an open circuit, there is no external resistance connected. We only have the internal one. No external resistor. Okay, no external resistor connected. I have this is point X and this is point Y, and here is my cell. This is the negative and this is the positive. Okay, this is an open circuit. So right for me, therefore we say that the voltage of an open circuit is equal to the EMF of the source or cell. As the name implies, the electromotive force EMF of a cell is regarded as the force that pushes electrons through a circuit. So what do we mean by that? We mean that what? That the EMF here is equal to what? The voltage. And don't forget that your V is equal to what? IR. Okay? Why did I use small letter R? Is because there is no external resistor here. So we are using R. R is the internal one. So my EMF is equal to what? I small r. Okay? So where EMF is equal to what? Electromotive force. So, and your I is equal to the current. Then your small r is what? The internal resistance. The internal resistance. So this formula is very important. For an open circuit, the EMF is equal to what? The potential difference. Okay? Is equal to the volt. So now let's talk about the second one, closed circuit. Number 2, the closed one. The closed circuit. All right. A circuit is closed when the source of electricity, that is either battery or cell, is connected to an external resistor, okay, or resistance R. If it is connected to external resistance, you talk about that it is what? A closed circuit. So if I have something like this, if I have a resistor here, let me have a resistor, big R, okay, and the resistor is connected like this. My battery being connected to the internal resistor. This one is the internal one, small r. Then I have my voltmeter. This is my voltmeter. This is my voltmeter. Okay? And then this is where my E is. The electromagnetic force. So this is a closed circuit. Okay? This is a closed circuit. So the relationship between this, and don't forget that a current is moving here. Your I is here. Don't forget the same thing here. Your I is here. Okay? Now, in a closed circuit, we have two types of two resistors that are acting here. Okay, so we have that what, that the EMF here is equal to what, let me call it V1 plus V2. Okay, the volt here and another volt here. So what do we have now? The volt here is what, V is equal to what, IR. So don't forget that V is equal to IR. Don't forget that V is equal to IR. So the EMF here is equal to what, I big R, okay, plus I small r, because we have two resistors here. Okay, so therefore my EMF, let me represent it with capital letter E. My EMF will not be what, the both currents are the same thing flowing everywhere. So I have my I in bracket of what, R plus small r. So this formula is very important. This is how to calculate the EMF of what, of a closed circuit. Then for an open circuit, there is no resistor or resistance that is there. All right, so the next thing we talk about is the efficiency of the cell. Efficiency of the cell. But before the efficiency of the cell, you can ask to calculate the voltage loss, the loss in voltage. So let me clean here. Now, if you're asked to calculate the voltage loss, okay, or voltage drop across the internal resistance, you will now know that what, that E, that I small r, just make the I small r subject of the formula to have what, E minus I big R. So this is formula to calculate the loss, the loss voltage. Okay, this is formula to calculate the loss voltage. All right, so you can call this or you can use big V and small v. You can use big V and small v, or V1 and V2, any one. So that is that. So let's talk about efficiency of a cell. Now, the efficiency of a cell, right, this is equal to the ratio of the power output to the power input. Please, the output first before the input. And don't forget efficiency in your what is it called, in machine. It is power output all over what, power input, or work done or work output over the work input. The output must come first. So efficiency is what, the power output all over the power input, always measured in percentage, don't forget. So my efficiency is equal to what, power output over what, power input times 100 over 1. So they are always measured in percent. All right, they are always measured in percent. So how do you get your power output? The power output is equal to what? The power output is the power delivered to the external resistor only. The power that is delivered to the external one is what? Is your power output. So I will now know that what, hence the power output is what? IV. Okay, and you know that P power is equal to IV. So and what is your V? V is equal to IR. So if you put it here, you now have what? Capital letter V is what I used here. So let me put the power output is 1, capital letter V. So which is what? I squared big R. That is I times another IR, which will give you I squared big R. So that is your power output. But for the power input is the total power delivered by the cell to in both external and internal. So for the power input, the power input is what? I in bracket of V plus capital letter V plus capital letter what? Plus capital small letter V. Okay, which will give you what? For the input, this is what? I big R plus I small r. So what do I have? They have I in common. So I have what? I squared in bracket of R plus R. So that is how to get your power output. So you now tell them that what? Efficiency is equal to what? The output first, which is what? I squared B R all over what? I squared in bracket of R plus R. So that is times 100 over 1. Times 100 over 1. So that is how to calculate the efficiency of a cell. Please note that. Very, very important. Okay. So the next thing, so let's solve calculations to illustrate what we have done so far. So, but if you look at that, in conclusion, efficiency is equal to, don't forget that we said it is what? I squared R all over I squared R plus R. I squared can cancel I squared now times 100 over 1. So which will give me big R all over big R plus small r, then times 100 over 1. If you don't want to use this one, you can use this one. This is your efficiency. Very important formula to note. Okay? That's formula for your efficiency, because I can cancel I. It is the same current that is passing through them. So the first question number 1, said a battery, page 2. Let me look for this one, has more issues. Page 262. No, it's even the same thing. Page 262. They said a battery of EMF 15 volts and internal resistance of 1 ohms is connected in series to a 3 ohms external resistor. They don't say calculate the current passing through the circuit. Now, if you look at this very well, you will know that they are talking about, what they are talking about here is a closed circuit. Why? Because it has both internal and external resistor. Okay, so I have my big R, the external one, to be what? 3 ohms. Okay, and then the internal one to be what? 1 ohm. Okay, so I know that for my EMF, so I know that my EMF they gave me is 15 volts. So I know that what? My EMF, in fact, I know that V is equal to IR. This is where it started from. Okay, V is equal to IR, but the V here is no longer volt but EMF. So you change it to EMF, because they are all measured in volt. EMF is equal to what? I, because they are talking about external and internal, both of them. You will not use just one of these, so you are going to use the big one plus the small one. This is a very simple formula to note. So you will now have that what? 15 is equal to I that I'm looking for, in bracket of 3 plus 1. So what do I have? 15 is equal to what? 4I. So my I will now be what? 15 divided by 4. So what do you have? You have 3.75 ampere. Very simple question. Very simple question. Okay? So question number 2. All right. Question number 2 said a cell of unknown EMF has an internal resistance of 2 ohms, an external resistor of resistance 10 ohms is connected. Once it is connected by external one, it's now a closed one. Okay, it's now a closed circuit. It's connected to the cell. Now, if the potential difference across 10 ohm resistor is 2.5 volts, then they now say find the the EMF of the cell, II. the current flowing through the cell. Solution. Okay. Okay, they gave us that a cell with an unknown EMF is okay. First of all, we need to calculate the current before we can get the EMF. Yes, if you cannot calculate the current, you cannot get the EMF. All right, and you should know that the same current is what is flowing everywhere. It's just one current that is flowing everywhere in a closed circuit. So I can just use these two men to get it. So I know that my R for the big R, I know that my big R is 10 ohms, okay? And I know that my small r is 2 ohms. And I know that my voltage of the big R, the V of the big R is equal to what? 2.5 volts. And I know that my current is equal to what? V is equal to IR. V is equal to IR. So my I is equal to what? V over what? R, which is what? 2.5 divided by 10, which is 0.25 ampere. So now, this is the current that passes through. In fact, I've gotten II. This is the current that flows through everything. So it will now help me to get my EMF. So what is your EMF? Your EMF is equal to what? Sorry, first of all, I will start from that. The same formula. V is equal to IR. But my V will turn to now my EMF. And since it's a closed circuit, my R will not just be one R, but big R plus small r, because it's a closed circuit. So what do I have now? My EMF, the current is the same thing, flowing everywhere. 25 in bracket of what? 10 plus 2. So I have what? 0.25 in bracket of 12. So 0.25 times 12, what do you have? 0.25 times 12, you have 3 volts. So that is my EMF. All right? So this is for I. So some questions, you need to get the I before getting the I. They want to confuse you by writing that I first so that you will think and tire. But if you know that you're supposed to get I first before the I in that particular question, you are good to go. You are good to go. Question number 3. Question number 3 said a battery of EMF 20 volts and internal resistance 1 ohms is connected to a resistor of resistance 3 ohms. Okay, then I say draw the cell. That's the first question. Draw the cell. Okay, draw the circuit diagram. Draw the circuit diagram of the arrangement, and then calculate I, the drop, the voltage drop, the voltage drop, the voltage drop across the resistance big R. Then II, the voltage drop across internal resistance small r. Okay, then IV, the lost volts. Okay, the first thing they say we should do is to draw it. Drawing it is very, very simple. We need to draw it. The first thing you draw is it has an external resistor. This is the external resistor, and that external resistor is your 3. This external resistor is connected to And what I have here is 20 volts. Okay, sorry, not here. That the volt is in the battery. So I have that it is like this, and then my cell. This is my cell, and in my cell I have that my EMF there is equal to what? The 20 volts. Okay, so and I have an internal resistor. Don't forget there's an internal resistor that is here in 1 ohm. This is the internal resistor, and I have that my current is flowing here. And what current is flowing there? Were we told the current? Okay, we are not told the current that is flowing there. So the next thing we were asked to find is what? The total. So they said the voltage across, the voltage drop across the resistor R. The voltage drop across the resistor R. Okay. Okay, we want to use ratio. Okay, using ratio to calculate this, we're going to have that for this is times 20 over the. Okay. So for the voltage drop, let's use ratio to calculate it. Number I, the voltage drop across the tray. That is what, if you use using ratio using ratio, you have for the across tray, you have what? 3 over the total. And what's the total? 3 plus 1, then times what? The voltage, the total voltage they are sharing, which is what? 20. So this is what? 3 over 4 times 20 over 1, which is 15 volts. Then II, the same, using the other one again, you have what? 1 all over what? 3 plus 1 times 20 over 1, which will give you what? Because the total voltage across them is 20. So I have 1 over 4 times 20 over 1, which is what? 5 volts. So that is that. We have gotten the two. So the next thing we are asked to calculate is what? Calculate the lost voltage. Okay. Before we calculate the lost voltage, we are supposed to calculate. I hope you know that we can do this without using this ratio. Okay. If you don't use ratio, you can still get the answer. But let us just finish what we are doing, then we can get it alternatively. Then I, the lost voltage. The lost voltage, don't forget what I told you about the lost voltage. The lost voltage is the small one. The lost voltage is found here. So I have that what? I big R is equal to what? The EMF minus I big R. Okay, so that is how to get your lost voltage. But before that, we need to get our what is it called? We need to get our, what am I saying? We need to get our current. We need to get our current. So we know that V is equal to IR. So but V now will turn to EMF. EMF is equal to what? I in bracket of big one plus small one. Don't forget. So what is my I now? To get my I will now be EMF divided by what? R plus R. So what do I have? The EMF there is 20 divided by that is 3 plus 1. So I have what? 20 divided by 4, which is what? 5 ampere. So I have 5 ampere here. So I'll say 5 times the small r1 is equal to, my IR, this is the loss, what is it called? The loss voltage. The loss voltage is equal to the EMF, which is 20 minus 5 times my big R is 3. So what do I have? 20 minus 15. So what do I have? That is 5 volts. So the lost voltage is 5 volts, which is the same thing as the voltage of the internal resistor. Okay? Yes. The lost voltage is simply the voltage of the internal resistor. The same thing, 5. That is your lost voltage. All right? So that is that for that. Okay? So like I said before, if you want to calculate it you don't want to calculate it using what is it called? Using percentage. The first thing you get is let us do it without using percentage. The first thing you get is your current. I've gotten my current now. They say we should calculate the loss voltage in where? In our R. So we tell them that V is equal to what? IR, which is what? 5 times what? Times the R there is 3. So the voltage there is equal to what? 15 volts. That is for my I. For my I'll tell them that V is equal to what? I small r. So which is what? 5 times what? My small r is 1, which is what? 5 volts. So if you add the both of them, it's still giving us the complete 20 volts. Then for your loss voltage is simply the voltage of the internal resistor. That is your loss voltage. Or use the formula for EMF and calculate it. Okay? So the next question. Let me see my time. Okay, we still have time. So the next question here said, where is the question? Question number 6. Question number 6, I mean question number 5, anyone. We have 2 cells. 2 cells each. Okay? 2 cells each having an EMF of 1.5 volts and an internal resistance of 2 ohms are connected in parallel to a 9 ohm resistor. Okay, then I say find the current flowing in the circuit. Solution. Okay, you can decide to draw it before you solve. You can decide to draw it. They say that 2 cells, they are 2 now, but they are connected in parallel. So I have parallel connection of cells, the big one, the small one. Okay, the big one again, the small one. They are both connected like this in parallel, but they are being connected by a resistor. I can decide to put my resistor here. Anywhere you like, you can put your resistor. They are being connected by a 9 ohm resistor. 9 ohm resistor. Then they said that I have an internal resistor here. Okay, sorry. That internal resistor should be close to them. That internal resistor should be somewhere close. So the internal resistor should be somewhere close. So maybe somewhere here. The internal resistor can be somewhere here, which is 2 ohms. Okay, but I have that this is 1.5 volts and another 1.5 volts. Okay, and don't forget that the potential difference across a parallel P to P, don't forget P to P, the potential difference across anything parallel are the same. So the total or the effective EMF, the effective or total effective EMF is equal to what? 1.5 volts. We are not adding, it's the same thing everywhere. Why? Because it is parallel connection. It is parallel connection. All right. So what are they say we should calculate? We should calculate the current. But I know that what? V is equal to IR. But I'm not using V here. What I'm using is what? EMF is equal to what? I in bracket of the result. The resistor I'm using here is what? Both the external and the internal. So what do I have? I have that my I is now what? EMF divided by what? R plus R. So what do I have now? The EMF I've gotten as 1.5 all over what? 9 plus 2. So which is what? 1.5 divided by 11. So what do you have? 1.5 divided by 11. Where is it? So 1.5 divided by 11, is it 2 or 1? So you can do that. 1.5 divided by 11, you can get that. Okay, but they say that this thing is parallel. Sorry, they say that this one is parallel to this. So if it is parallel to this, we are not just adding. They are not in series. They are in parallel. So let me say that it is somewhere here. Let me say that it is somewhere here. I don't know anyways, but let me just say that it is somewhere. Let me say, oh, they say that it is in parallel. Since it is in parallel, what do we do for parallel connection? So they say that total resistance. Okay, each of these has an internal resistor. Sorry, this is 2 ohms and another 2 ohms. Each of them has an internal resistor and they are connected in parallel, 2 ohms. Okay, so you have to find their effective resistance. Yes, you have to find their effective resistance. So for R, so I have 1 over small r is equal to what? 1 over R1 plus 1 over R2 because it is parallel connection. But I told you that the short form to get it is what? R will now be what? The multiplication will be up while the addition will be down. So I have what? 4 over 4, which is 1 ohm. So the effective resistance for the internal one is 1 and not that 2, please. You have to be very, very careful. That's the mistake I made. So I have what? That V is equal to IR, V is equal to IR. So my V will turn to EMF and is equal to what? I in bracket of this one will now be R plus small r. So what am I having? The effective here is 1.5. So but the I here, I'm looking for my I in bracket of what? 9 plus 1. So what do I have? 1.5 is equal to 10I. So my I will now be what? 1.5 divided by 10, which is what? 0.15 ampere. That is the correct thing to do. Okay? All right. That is that. So the next question. So the next question here, question number 6. Question number 6 said two cells each of EMF 3.0 volts are okay, and the internal resistance of 2 ohms. Internal resistance of 2 ohms are connected in series. They are now in series, are connected in series. Then a 12 ohm resistor, is connected. A 12 ohm resistor is connected. Where is it connected? It's connected in series as well. In series to the cell. They now say calculate I, the current flowing in the circuit. I. They say the voltage drop. Okay? The voltage drop or the voltage loss. Or is the same as voltage lost. And I told that the voltage loss is the voltage in the internal side. But it has a way of calculating it anyways, though you will still get the same answer. So let us move. You can draw it so that you understand what you are doing. You can draw it so that you understand what you are doing. If I'm drawing it, I'll have that 2 cells. The first cell has a resistor, an internal resistor of 2 ohms. And this is the first cell. Okay, sorry. This one will be big. This one will be small. Connected to this one will be big. And this one will be small. Then this one has its own resistor, 2 ohms again. These are the internal one, okay? But they are being connected. I don't know how to put it here. They are being connected by a resistor, a big resistor of what? 12 ohm. Okay, they are being connected by a resistor 12 ohm, and I have my current flowing here. So what they say we should calculate, and what I have here is 3 volts and 3 volts. So now the effective EMF will now be what? 3 plus 3, because they are in series. You know, if they are in series, you add, but if they are in parallel, they are the same. So you're not adding, you just pick one person. So I have 6 volts here. Now, don't forget that the internal resistor, the total internal resistor should be R1 plus R2. Why? Because they are in series. So I'm going to have 2 plus 2, which is what? 4 ohms. Then I can now calculate my current. I know that V is equal to IR, but I'm not using V here. I'm going to use EMF is equal to what? I. I'm not using big R alone. It should be big R plus small r. Okay? So what do I have now? My EMF is 6 is equal to what? I that I'm looking for in bracket of the big one there is 12 plus the small one there is 4. So what do I have? 6 is equal to I, 16I. This plus this is 16I. So my I will now be what? 6 divided by 16. So what do you have? You have 6 divided by 16. So what do you have? Where is the question? You have 0.375 ampere. Okay, I've gotten this. So the voltage drop or the voltage loss is the small one, which is I small r is equal to the EMF minus what? I big R. Sorry, I big R. So this I small r is what we call the voltage loss. The voltage loss. So is equal to what? Then E minus I big R. So what is my E? My E I got as 6 minus my I big R. My I is now where's my big R? My big R is 12. So I have 0.375 times 12. So what do you have? 6 minus, multiply that, you're going to get 4.5. 4.5. So if you subtract that, you're going to have 1.5 volts. So that is your voltage loss. 1.5 volts, and that is your voltage loss. Okay, so that is that for that. The next question, here said number 6. They say three cells, each 2 volts, and internal resistance 0. 3 cells 2.5 volts and internal resistance 0.5 volt again. No, that's a mistake. The internal resistance is 1.5 ohms. Where is it? That's a mistake. Okay, it said three cells 3.5 3 cells 2.5 ohm with an internal resistance of 0.5 ohms. 0.5 ohms, please. How can you say volt for resistance? 0.5 ohms are connected to a 2 ohm resistor in series, okay, with a parallel combination of 2 3 ohm with 2 3 ohm resistance, sorry. Okay, then I say calculate I effective external resistance II, the current in the circuit. III, lost voltage of the battery. IV, current in one of the 3 ohms resistors. Okay, let us solve this. This is a very simple question. But before that, we can decide to draw it. Oh, you can decide to draw it. So drawing it, the first thing they say that what 3 these things. So the 3 of them. Let me get the 3 of them. This is the first one, the second one. Or do I give space? Okay, the first one has an internal resistor of 0.5 ohms. But you may not put it. Let me just draw the cell. This is the first cell, the big one and the small one, the big one and the small one, and finally the big one and the small one. Okay, and all of them has this is 2 volts. The 2 volts has 0.5 ohms in series. 2 volts again has 0.5 volts in series. Then 2 volts again. 2 volts again has 0.5 ohms in series. Then they are now being connected by a parallel, they're being connected by 2 ohms and 3 ohms in parallel. So they came here, they are being connected by what? A resistor of 2 ohms and another one of 3 ohms. That's all. That's all. Okay? And I have my current flowing. My current flowing. So, what did they say we should calculate? Solution. They say the effective external resistance, and they are in parallel. So I have one of the R, big R is equal to what? 1 over 2 plus 1 over 3. But I told you how to get it. Your big R will now be, if they adjust 2, the multiplication is up, while the addition is down. So what do I have? 6 over 5 ohms. Okay? I've gotten my I. Very simple question. Then my II said the current in the circuit. Okay, the current in the circuit. First of all, I need, since they are in series, the voltage, my total EMF will now be what? 2 plus 2 plus 2, which is what? 6 volts. My total R will now be what? In series again, 0.5 plus 0.5 plus 0.5, which is what? 1.5 ohms. And I will tell them that what? V is equal to IR. But I'm not using V. I will change my V to what? To my EMF. I. Then my arrow is now the combination. The big R plus the small r. So what do I have now? I'm looking for my I now. My I will now be what? EMF all over what? R plus R. So what do I have? Or rather, let me put in everybody first. My EMF is 6. 6 is equal to my I. I'm looking for my I in bracket of my big R is 6 over 5 plus my small r is 1.5. 1.5 means 15 over. In fact, let me put this one in point. 6 divided by 5 will give me what? Where is 6 divided by 5? Permit me to put it in point because I don't have my calculator. Where is it? Sorry. This is a very big mistake. Jesus. Why would I do such? Let me read it very well again. Oh, sorry. They say that in fact, even the drawing itself is very, very wrong. Even the drawing is very, very wrong. Yes, because look at what they said. They said 3 cells of each this, okay, are connected to this in series. They are connected to 2 ohms in series. 2 ohms is in series. Then that 2 ohms are now being connected to to another two 3 ohms resistor in parallel. So it is here that I can have that I can have here and here. This one is the 3 ohms. Sorry, pardon me for that mistake. This one is another 3 ohms. So the both of them now are, this is the perfect drawing. So now these are the external ones. So let us now get the effective external resistance. So let us resolve this one so that they will be in series before I can now add it to this one. So 1 over R in parallel will now be what? 1 over 3 plus another 1 over 3. So I told that R in parallel, how do you do it? You say 3 times 3 all over what? 3 plus 3, which is what? 9 over 6. And 9 over 6 is 3 over 2 in ohms. Okay, 3 over 2 is 1.5. 1.5 ohms. Okay? So now, the R now that I'm looking for now will now be what? R in parallel plus these two, because they are all in series. So what do I have now? 1.5 plus 2, which is what? 3.5 ohms. This is my R. Then my small r, they are all in series. So I'll have it to be what? 0.5 plus 0.5 plus another 0.5, which will give you what? 1.5 ohms. Okay? Then my EMF, they are all in series. If they are in parallel, I'll take just one person. But because they are in series, I'll add 2 plus 2 plus 2, which will give you what? 6 volts. Okay? So I know that my V is equal to IR. I'll change this my V to my EMF, sorry. Then my I is what I'm looking for. But this my R will change to the big one plus the small one, both the external and internal. So my EMF is 6 is equal to the I I'm looking for times my big R is 3.5 plus my small r is 1.5. So what do I have? 6 is equal to 3. That is 5i. So my I will now be what? 6 divided by 5. So my I will now be 6 divided by 5, which is what? That is 1.2 ampere. So that is that. So the next thing we should calculate is this is our I and this is our II. Okay? So our III is what? The loss voltage. And the loss voltage is simply small one. This is the loss voltage. And this is equal to what? The EMF minus what? I big R. So this is my lost voltage, which is equal to what? My EMF gave me, my EMF is 6 minus, my I is what? 1.5 times, sorry, 1.2 times 3.5. So what do you have? 6 minus, multiply them, you have, where's the lost voltage? Right? 1.2 times. So everything will give me 1.8 volts. Everything will give me 1.8 volts. So that is that. So the next one they say is what? That we should calculate the current in one of the three. So the current in one of the three of these. Okay. So, but do I know that? Okay. Look at what I'm going to do. First of all, let me get the current that passes through this place. The total current that comes in here. Okay. I know that my V is equal to IR. V is equal to IR. So, what is the volt that is entering there? Let us check. Okay. So what the total this thing is okay. So we have that the current that is passing through this circuit is the same. The current that is passing through this circuit is what? 1.2. Okay. So 1.2 voltage is what is entering here. It is being shared there, and they are of the same ratio, 3:3. So just divide it by 2. So the current that passes through each of these is 0.6. Divide it by 2 because they are equal. So if you take it by the ratio, can I clean this? Okay. So I have that what? According to by ratio, I have that what? 3 all over the total. 3 plus 3 times the total current that passes there is 1.2. So what do I have? 3 over 6 times 1.2, which is what? 0.6 ampere. So that is that. All right. The next question. Right. Question number 7 said a voltmeter is connected. A voltmeter is connected in parallel. Is connected in parallel. Okay, with a variable resistance R, which is in series with an internal which is in series with an ammeter, which is in series with an ammeter and a cell. Then I say the cell is of EMF E and internal resistance R, comma, they say for one value R1 of the variable resistance, comma, the ammeter reads 0.3 ampere and the voltmeter reads 0.9 volts. Okay, and I say for another value R2 of the variable resistance, comma, the ammeter reads 0.25 ampere and the voltmeter reads 1.0 volts. Full stop. Then I say neglecting the resistance of the meters, that is the internal resistance. Okay, then I say find the value of R1, comma, R2, comma, E and okay, neglecting, oh, that is not even the internal one, and your small letter R. Okay, so this is your assignment. So drop your answer at the comment section. Okay, so in our next video we'll now be talking about okay, let's just solve one question for effective that is efficiency. Just one question for efficiency. So this is your assignment. So let's solve just one question for efficiency, They said that what? Question number 8 said that a cell of internal resistance 2 ohm, okay, supplies current of supply current to a 6 ohm resistor. Calculate the efficiency of the cell. Okay, what did I tell you about efficiency? Efficiency is simply efficiency efficiency is simply power output first, all over what? The power input times 100 over 1. And what is power output? I squared R, big R. But the for power input is both the small one and the big one, which is what? I squared uh, big R plus small r, then times 100 over 1. So the I here is taking care of I here. So I'm left with what? R over what? R plus R times 100 over 1. So what is my big R? My big R is the external one, which is 6 all over. My small r is the two of them. That is 2 plus 6, then times 100 over 1. So I have 6 over 8 times 100 over 1. So if you do that, you are going to be getting 75%. So thank you very much for watching. Please like, share, and subscribe. Bye bye.